the 2-1, 2-3, 2-4 review. We're starting with some synthetic division here. So for synthetic division, again, we're dividing by a linear factor. And you put the 0 of the factor. So the thing that would make the 0 is -3. So we put a -3 right here. So -3 goes right there. And then we put the coefficients of what's in our numerator out to the side. So we got 3. Now, notice, this is 3x to the 4th. This jumps onto x squared, so we're missing the x cubed term. So we want to put a 0 in for the x cubed term to capture the fact that that's missing. Then we need our 2 for the x squared term. Then we got the -8 for the x term, and the -4 for the constant term. What we're going to do is draw a line, leave a space to write some numbers in these spots, and then we're going to box off this final thing. Remember, this represents our remainder right here. Okay, so first step is always to bring down this first coefficient, so that's a 3. Then we multiply -3 times 3 and write the result right here. So that's -9. Then every time we just add these two numbers. So we get -9 here. -3 times -9 gets us to 27. Add these two, we get 29. 29. -3 times 29 is, what is that? -87. This is getting a little large. Add these together, we get -95. Then we multiply by 3, now -3 one last time, and we get positive 285. Add these together, and this result is our remainder. Now remember, what does all these numbers represent? Well, these numbers represent the result of the division. So if this was an x to the 4th term, then this one represents the coefficient of the x cubed term. So remember, this is x to the 4th, x cubed, x squared, x constant. So it goes down by 1. So this is the x cubed term. So we write 3x cubed minus 9x squared plus 29x minus 95 plus our remainder, 281, over the thing we divided by, which was, remember, x plus 3. So that is our final answer right there. Boom. That's synthetic division. All right, another synthetic division. We're dividing by x minus 2, so we put a 2 right here. So 2 goes there. Coefficients go out to the side, so I got 4, -1, -8, 4, 1. No zeros this time because we had a term for every x exponent. So we bring down our 4. We do 2 times 4 and write 8. Add those together, make 7. 2 times 7 is 14. Add those together, we get 6. 2 times 6 is 12. 4 plus 12 is 16. 2 times 16 is 32. And remember, this last one we always box off because it represents our remainder. So we added those to get 33. All right, again, just a reminder. Remember, this represented the coefficient of the x to the 4th term, so this one has to be an x cubed term. Always one less than what this is. So 4x cubed plus 7x squared plus 6x plus 16 plus our remainder, 33, divided by what we're dividing by, which is x minus 2. And that right there is your final answer. Okay, so next, we got one more synthetic division. So we've got x to the 4th. So we are dividing by x minus 3. So we got to put a 3 right here. Since we put the 0 of what this would be in here. And I got another missing term. So I got a 1 for the 4, -2 for the coefficient of the x cubed term, 0 because there is no x squared term, then 6, then -5. All right, do our thing. Bring down our 1, multiply by 3 and put the result here. Add those together, we get 1. 3 times 1 is 3. Add those together, we get 3. 3 times 3 is 9. Add those together, we get 15. 3 times 15 is 45, and that's our remainder, -5 plus 45. So again, these all happen to be x to the 4th, but don't let that confuse you. Because this is x to the 4th, this is x cubed. It's not always x cubed, but it sometimes is. Only when this is x to the 4th. So we got 1x cubed plus 1x squared plus 3x plus 15 plus our remainder 40 over what we divided by, which is x minus 3. That's our final answer there for dividing with synthetic division. Okay, so we are evaluating with the remainder theorem. So we've got, for this function, we are evaluating f of 4 using the remainder theorem. Remember, what this means is that essentially the remainder theorem states that if I divide this function f of x, so if I want to evaluate f of 4, what I have to do is divide this by x minus 4. Notice that's the opposite of this. So I divide by x minus 4, and for the result, the remainder will equal f of 4. Okay? So if I'm dividing by x minus 4, I know the number in the box, so I'm using synthetic division, is 4. So 4 goes in the box. Notice that's the same number as what we're evaluating. And now I just divide. So I've got x cubed, that's 1, negative 2, negative 1, and 2. This one did not need any missing terms because we had a term for every x. Bring down our 1. 1 times 4 is 4. Add these together, we get 2. 4 times 2 is 8. Add those together, we get 7. 4 times 7 is 28. Add those together, and we get 30. Now remember, normally this is our solution. That's what we want when we do synthetic division. But for this, when we use the remainder theorem, the remainder is what we want, because it's an alternative way to evaluate f of 4. So we know f of 4 equals this remainder, which is 30. Now, of course, you could have just found f of 4 by plugging all these in, but that wouldn't have been doing it using the remainder theorem. So that's the key here. Use the remainder theorem to evaluate f of 4. All right. The study guide had a typo where it didn't have the rest of the problem here. So here's the rest of the problem. If you haven't done it yet, feel free to try it first, then check your answer. So we're doing f of negative 3 using the remainder theorem for this function g of x, which doesn't make sense. So we're going to say it's g of negative 3, not f of negative 3. We want g of negative 3 using this function g of x using the remainder theorem. So we put negative 3 in the box because, again, we're dividing this whole thing by x plus 3. Remember, that's what the remainder theorem states. Take home messages, though, you got to put negative 3 in this box. And now we put our coefficients. So we've got negative 1. There is no x to the fourth term, so we put 0 for that. We've got a 2 for the x cubed term, negative 4 for the squared term, positive 7 for the x term, and negative 10 for the constant term. All right, these numbers might get big, hopefully not too big. So we bring down our negative 1, multiply these, we get 3. Add them together, we get 3. Negative 3 times 3 is negative 9. Adding together, we get negative 7. Multiplying these two, we get 21. That's negative 3 times negative 7, 21. Add these together, we get 17. Negative 3 times 17 is negative 51. Adding those two together, we get negative 44. And then 3 times negative 44, first triple digit, we've got positive 132. Okay, and remember, this is our remainder. This is our answer of interest, because remember, the remainder is equal to g of negative 3. So this equals g of negative 3. So just cleaning it up, we can write g of negative 3 must be equal to 122, which the largest number we dealt with there was 132, which if I had just plugged in negative 3 using our traditional method and doing negative 3 to the 5th power, we would have gotten up into the 200s or so. So it would have been a little larger numbers to add and subtract, which is what makes this a useful tool. All right, last two questions. So we've got number 27. We want to solve this equation given that 2 is 0. Given that 2 is 0. So let's see what we got here. So if we think logically about this, if 2 is a 0, then we can conclude that x minus 2 is a factor. Because in order for 2 to be a 0, then this thing must factor into x minus 2 times something, right? Equals this. Well, if x minus 2 times something equals this thing, 2x cubed minus 5x squared plus x plus 2, that's just this original function, then we know that if we divide it by x minus 2, then we should get the rest of this. Because this rest of this is what's going to be is how we're going to be able to find our other two solutions to this equation besides 2. So let's find it. So we divide this original by x minus 2. So when we divide this by x minus 2, we put 2 in the box if we're doing synthetic division. And put my coefficients, 2, negative 5, 1, and 2. Bring down my 2. 2 times 2 is 4. Bring that, so negative 5 plus 4 is negative 1. 2 times negative 1 is negative 2. And this together we get negative 1. 2 times negative 1 is negative 2. Now, haven't gotten 0 yet for any of the ones on this review. So is this surprising? Well, it shouldn't be surprising, because when it's 0, that means that x minus 2 is a factor, which we already knew because 2 was a 0. So remember, that's the factor theorem, technically. That states that when the remainder is 0, what you divided by was a factor of your what was in the numerator. Okay, so what this means is that this thing here in the question mark is this result, our synthetic division. So it's 2x squared minus x minus 1. So I know that this thing right here factors into x minus 2, because 2 is a 0, times the result of our division when we divided by x minus 2. So I got 2x squared minus x minus 1 equals 0. So once we get to here, we know we can solve both of these by setting them separately equal to 0. I already knew 2 was a 0, so I knew that had to be one of my solutions to this equation. But for the rest of this, I'm going to use a quadratic formula. Now you could try factoring it using divide and slide, but I'm gonna stick with the quadratic formula for this. So for our quadratic formula, we've got x is equal to negative b, so that's negative 1, so positive 1, plus or minus the square root of b squared, that's negative 1 squared, minus 4 times 2 times negative 1, all over 2 times 2. So I've got 1 plus or minus the square root, that's going to be 1 plus 8, which is 9, that's convenient, all over 4. So I got 1 plus or minus the square root of 9, which is 3, all over 4. So I got 1 plus 3 over 4, which is 4 over 4, which is 1, and 1 minus 3 over 4, negative 2 over 4, which is negative 1/2. So my three solutions are x equals 2, then 1, and negative 1/2. And those are my final answer. All right, lastly, we've got to solve the equation, and this is the same type of equation, same type of one, but we've got x cubed minus 2x squared minus x plus 2, given that negative 1 is a 0. So again, if negative 1 is a 0, x plus 1 must be a factor. So that the first thing we need to do is divide this by x plus 1 to figure out what else. Now, technically, solve the equation. Shouldn't be f of x, should be 0 equals. We want to solve this equation given that negative 1 is a 0 of this. Okay, it's one of the solutions. So it's 0 equals this. But again, we want to factor it. So we know that because negative 1 is 0, it's got to factor into x plus 1 times something. We got to find out what this thing is. So we're going to divide it to figure out what this thing is. So we divide by x plus 1. So throw in negative 1 in the box. We got 1, negative 2, negative 1, and 2. Bring down our 1. Negative 1 times 1 is negative 1. Negative 3. Negative 3 times negative 1 is 3. Adds to 2. Negative 1 times 2 is negative 2. Rounds off with a 0, confirming that this, in fact, is a factor. So x squared minus 3x plus 2 is this mystery other polynomial. So x squared minus 3x plus 2. And now we can just solve this how we need to. Now, notice this one is nice in that it factors. Think of two things that factor to 2 but add to negative 3, or that multiply to 2 but add to negative 3. Well, we got x minus 2 and x minus 1. Still got this x plus 1 over here. So now I can solve each of these by setting them all separately equal to 0. Again, if you can do this without this step, that's okay. But this is what we're actually doing. So we got x equals negative 1, x equals 2, and x equals 1, which I can just write all together by saying -1, 2, and 1. So final answer, and that concludes our work on the 2.1, 2.3, 2.4 study guide.